Hello, my name is Sylvie Turgeon. I'm a professor at Science and Food at Laval University and a researcher with Stella and at the NF. For this presentation, will be with Audrey Gilbert, a research professional on my team, and we will present to you work done on validation of a quick and simple method to characterize the structure of stirred yogurt. If you recall the context, in the past, we undertook a project where we studied connections and links between composition resistance and final composition and shear resistance. And we were able to put in place a quick and simple method to characterize the structure of stirred yogurt using surface analysis by digital imaging. The project aims to validate this method and transfer it to the industry so that it be supporting research and development and quality control. If we recall the manufacturing of stirred yogurt based on fermented milk, which is acid pH for a gel, the stirred yogurt involves pumping and listing to break the gel mechanically and to get stirred yogurt. Concretely, we will have a gel that will be broken down to get small units of gel that we call microgels. And the method that we developed here, we would set up a spacer using what we're going to stick onto a microscope using nail polish, and then we're going to spread yogurt on this slide. This method allows us to not dilute the yogurt, which could be problematic, and we'll be able to look at this information and get some very clear indications. So here you've got the type of photo that we're going to pick up with our digital camera, and by using the image analysis, we'll be able to characterize the microgel that we talked about, and we'll have the surface and the distribution and even the gel heterogeneity. So here's what we do. Once we have our product, we will then spread it onto our spreader. So we put it very gently on the spacer, and then using another slide, we will create a very fine level of yogurt. Once the slide is done, we will put it on top of the digital camera so that we can then use the micrometrics and focus specifically on the slide. We take the image as we move the slide above the digital camera, and by using the computer, this is something that is relatively clear. If you see the following example, so yogurts 1 and 2. Yogurt 1 has a much denser structure with larger microgels, whereas yogurt 2 has smaller microgels. If we focus on the size of microgels here with the images, we will supply all of the images obtained in the program, and with the gray density in the image, it will segregate different microgels in each image. Here you have each small microgel, so each photo, and then we have access to a summary. In the summary, we will find the size of the microgels, the amounts of microgels, and this will allow us for more information. Then we can look at data in Excel. We can look at how things are distributed. We can distinguish between yogurt 1 and yogurt 2, and we can look at the calculation based on image lists. The project allowed us to study 8 different representative products representing diversity in fat, stabilizers, and added sugars, and available commercially in grocery stores on the market. The project aims to target physical properties of yogurt, so their texture, their levels, and the microgel size as analyzed by the image results. And what we're targeting here, so the spin-offs of the project, are that this approach becomes a decision-making tool that's easy to use, and that supports either the development of new products or quality control. I'll close by thanking our financial partners, Novalait, obviously, and the Minister of the Economy, the Ministry of Quebec, and all participants. If you have any questions, please don't hesitate to contact us at Audrey or Sylvie at these addresses here, and we would be happy to answer. Thank you very much, Audrey. Have a good day.